Hello, geometry. Welcome to lesson 2 on proving lines parallel. So, in the last lesson, you learned about parallel lines and the different angle pair relationships. And today, we're going to use those angle pair relationships to prove the lines parallel. So, you must show something special about your angle pair relationships in your pictures. So, in these problems, show angle pair relationships. So in these problems, you have to maybe show that a pair of corresponding angles are congruent. Then the lines are parallel. Maybe you'll show a pair of same side and shade angles are supplementary. Then the lines are parallel. So you arrive at this idea that the lines are parallel. Okay, so example 1, it says, suppose two lines are not parallel. Can corresponding angles still be congruent? Well, if you look at this picture here, so we have two lines, T and M, that are not parallel. And then we have this transversal S. What I'm going to do is I'm going to draw a parallel line through this intersection point to line M. So I'm going to draw this line. It's supposed to look parallel. Okay, I'm going to call this line L. And yes, it's going to be parallel with line M. And I'm going to throw in some angle numbers here. So angle 1, angle 2, angle 3. So for lines M and T with transversal S, for lines M and T with transversal S. So these are the non-parallel lines. The 120-degree angle corresponds with angle 1 and 2, with angle 1 and angle 2. So the idea here is that, angle 2, or no, sorry, the 120-degree angle is in the top right. Angles 1 and 2 together are in the top right of this intersection, right, with line T and line S. But however, if lines L and M are parallel, right, if L is parallel to M, then this forces the measure of angle 1 to be 120 degrees by the corresponding angles theorem, So this angle right here must be 120, because if the lines are parallel, corresponding angles are congruent. So angle 1, which is just this angle here, is congruent with the 120. But wait, if without the parallel line L, if for T and M, if the 120 corresponds to angle 1 and 2 together, then the 120 must be equal to the measure of angle 1 plus the measure of angle 2. But up here we just said that the parallel line forces angle 1 to be 120, so angle 1 must be 120. If we subtract the 120 from both sides, right, minus 120 minus 120, this would force the measure of angle 2 to be 0 degrees. But angle 2 cannot be 0 degrees, right? If angle 2 is 0 degrees, that means that line T and line L would have to be on the same line. So this is a contradiction, all right? So because angle 2 cannot equal 0, we're going to say that thus the measure of angle 1 plus the measure of angle 2 would have to be greater than 120 degrees. So if two lines are not parallel, then the corresponding angles cannot be congruent. Then the corresponding angles cannot be congruent. And there you go. Sorry, the 2 is supposed to be in there. So hopefully you followed that along, right? Again, this is one of their theoretical kind of walkthroughs of why lines must be parallel in order for corresponding angles to be congruent. And we can do similar things for the other angle pairs as well. So now we're going to get into the theorems from today. So they're all what are called converses. If you remember what a converse is, it's where you take the hypothesis and the conditional, the hypothesis and the conclusion of a conditional and switch them around. So this is the converse of the corresponding angles theorem. So now it says, if two lines in a transversal form corresponding angles that are congruent, then the lines are parallel. Right? So if in this picture 1 and 2 are congruent, then line L and M would be parallel. Same thing for the next ones. So same thing here for the converse of the alternate interior angles theorem. So again, if you have alternate interior angles that are congruent, then you can say the lines are parallel. So in this picture, if angle 1 and angle 2 are congruent, then L must be parallel to M. All right, so let's do a flow proof. Now, I don't think we've done a flow proof before in our small. We've done two column proofs. I think we've done paragraph proofs, so not a flow proof. So it says write a flow proof to prove the converse to the alternate interior angles theorem. So remember, if you're trying to prove it, that means you cannot use it. So we cannot use the fact that angle 1 and angle 2 are alternate interior angles. We have to go a roundabout way to proving that these two lines would be parallel. So maybe we'll use 1 and 3 or 2 and 3. Who knows? Okay, so again, in a flow proof, we're going to use arrows to show logical connections. So first, we're going to write down the given. So angle 1 is congruent to angle 2. And we're going to put the word given right underneath it. Okay, just kind of out in space. So now from this picture, right, we don't know the lines are parallel, but from this picture, do we know any other angle relationships? Well, yes, we do. We know that angle 1 and angle 3 are congruent because they're vertical angles. I'm going to put that right here underneath it. Angle 1 is congruent to angle 3. And this is because of the vertical angles theorem. So now notice that these two congruent statements both involve angle 1. So if we bring them together, we can use what's called the transitive property to say that angle 2 is congruent to angle 3. This is by the transitive property. If you remember, the transitive property mentions that if two angles are congruent to the same angle, then they're congruent to each other. That's the transitive property. And now we know that 2 and 3 are congruent. And 2 and 3 are corresponding angles. So since we showed that corresponding angles are congruent, we now can say that L is parallel to M. And that would be by the converse, CV converse, to the corresponding angles theorem. And there's a basic proof. All right, nice. Okay. Next one here. So the converse of the same side interior angles postulate. So converse, same side interior angles postulate. So again, if we have same side interior angles that are supplementary, then the lines are parallel, right? So in this picture, if 1 and 2 add up to 180, then the lines are parallel. So in this picture right now, right, 60 plus 120 is 180. So we would be able to say that this line is parallel to that line, right? So the lines are parallel. Now let's explore this real fast. Let me take down these. Let's see if it jumps right to it. So what we're going to do is we're going to move some lines around. So let's move these. So notice, right, they're not parallel, so they don't add up to 120, right? But notice that when they are parallel, they add up to 180. Add up to 180. Same thing here. If I move this line, they're not parallel, doesn't add up to 180. But if I move it back to 60, there you go. And now if I try to move it, so say this one is, what? We'll go 100. This one better go to 80. And because those two angles add up to 180, the lines would be parallel. So there you go. All right, last idea on this video here is going to be, this example, I'm sorry, I skipped one. The converse of the alternate interior angle, exterior angles theorem. Sorry, skipped it. So here we go. So it says for the converse of the alternate exterior angles theorem, it says that if you have two lines in a transversal that make alternate exterior angles congruent, then you know that your lines are parallel. So in this picture, if 1 and 2 are congruent, then you know that lines L and M are parallel. So in this picture, 120 equals 120. So that means that your lines are parallel. So this line is parallel to this line. Again, we'll explore this real fast and show you that if you were to move one of these lines and make them not parallel, no longer will your alternate exterior angles be congruent. If you want to make the lines parallel again, you better make this angle a 144, and that would then make them parallel. Good. Okay, so that's the end of the first video. The second video is coming up with some more examples.